This is the Quality Grind podcast presented by Medvacon. Conversations that go beyond compliance. Sharing insights geared toward helping you navigate the everyday grind of regulated life science industries. Here are your hosts, Joe Toscano and Mike Kent.
Welcome back to The Grind, everyone. Mike Kent along with you today, flying solo with our special guest, Jose Mora. Jose is here to talk with us a little bit about lean principles and specifically how those principles can be applied to the bane of our existence in regulated life sciences. We all have procedures, we all have protocols, we all have documents that we use every day. And more often than not, we have a ton of challenges with those documents. So Jose is here to illuminate us on some strategies that we can use in order to make those documents much more user-friendly, another buzzword that we love here, as well as much more effective and easier to manage overall. Jose Mora is a principal consultant specializing in manufacturing, engineering, and quality systems with over 30 years of experience in the medical device and life sciences industry. His expertise lies in manufacturing, process development, tooling, and quality systems. And Jose holds a bachelor's degree in mechanical technology from Purdue University. Jose Mora, it's great to have you here on the Quality Grind podcast. Welcome, sir.
Thank you. Glad to be here. Glad to have the opportunity to talk about one of my favorite topics, if not my favorite topic.
One of the things we want to be able to do is ensure that people who need to use those documents will actually want to use those documents. So making them as accessible and user-friendly and easy to use as possible is really key. And that's where I'm hoping your familiarity with lean principles and how they apply to controlled documents can really help us today. Why don't we start with having you tell us a little bit about you, how you got into regulated life sciences, and how you got to the point where you are today.
So from the very beginning, I've had a bit of an idealistic aspect to me, but I also, I guess I think of it as having my head in the clouds, but my feet on the ground. It's always been a struggle between my ideal and reality, and I always try to live up to the ideal, but understanding very much the facts around me. So when my career started with, I graduated, and then I wanted to do something that was going to help humanity. Obviously ideal, so that ruled out destructive things. I wanted to do constructive things. So my first thoughts were, my first opportunities were either in the field of agriculture or something to do with health. Those seemed pretty logical. So my first job was in agricultural equipment, and I ended up, because I had studied hydraulics, I learned about hydraulic systems, and I ended up in a job designing hydraulic systems for hitches, but for tractor hitches. But I also learned a lot about datums and data and how important it is for things to be properly related. Fast forward through the next several decades, I went into medical devices about a year and a half after my first job, and it was a plant that made surgical instruments, handheld. So I had taken from the first job how important it is to have datums and how to have things properly dated. So I get into an environment where the whole shtick was about handcrafted instruments and all these people, and I'm like, okay, wait a minute, you're going to make an instrument, but where do you start? If you're going to make a pair of scissors, I would think the most important thing is the one common place was just a hole and everything. So I immediately started applying the engineering and critical thinking no matter where I was. So at some point, I started questioning, why are documents so complicated? Why are we repeating things so often? Why is it so difficult to communicate? And after about half of my career, I came to a startup company, and I had plenty of experience on how the traditional ways, but this startup company they did something very strange. This was a small R&D group, and of course they were focused on the product, so they had 28 almost identical procedures, except the
Wow.
only variant was the product specific parts. Now, from their point of view, that was fine. Okay, I'm going to look at this product. So that made perfect sense. But I was brought in to set up manufacturing. And if I have a manufacturing process and I want to make a change in a procedure, I don't want to have to go and change 28 documents. And I'll probably miss a couple. And next thing you know, I have a lot of confusion.
Right.
But as I started to say, wow, this is wrong, and then I say, wait a minute, they're onto something. There are pieces of that information that are product specific. The rest is process specific. And I started saying, well, why do we even mix those up? So as I went to set up the manufacturing, I in a startup you have to wear many hats. So I had to wear the hat of purchasing, receiving, stock boy, setting up the manufacturing line, validation. Sometimes I had to do shipping. So
Mhm.
one of the benefits of that is when you're wearing those hats, you get to witness every single part of the process.
Right.
So I started thinking, okay, I'm an operator and I'm gonna do something. So imagine the typical work instruction. Okay, um, make sure you understand the purpose of why you're doing this. And I'm like, wait a minute. If I'm an operator, I hope by now I know why I'm doing this. I the first time shouldn't be in those work instructions. The scope, well, I hope I know what the scope is. So when we get to the document, the part that is really interesting to the operator is probably section 7, where it's like, okay, pick up part A, pick up part B, and put them together, and so
Right.
forth. So it is really about what the operator is doing. Now, because I was wearing many hats, I had the opportunity to witness the process. So first of all, as a planner, if I'm going to build this particular assembly, I am not asking the operator to find the right document. I hopefully know what is the correct work instruction, what are the parts, what are the components, what are the records that I'm going to need, and I'm going to ask the people to set up that production line. So that belongs somewhere else. That information is really, if you think of a regulation as here's what you have to do, here's the objective evidence that you did it. So the device history record is the objective evidence that you did it, but what feeds into the device history record is the device master record. Now, if you're building an assembly, you're taking a subset, you're taking part of the BOM, but not just the BOM of the components, the BOM of the documents that you're going to need to build that subassembly. So that is the document that is the one that contains all that other information, which includes, by the way, you need these work instructions to do this. The evidence of that is its mirror image, which says, hey, here's the evidence that I did what this said. So when
Right.
I am the planner, I am using that section of the device master record to set up that line, the shop floor paperwork, all the tools, equipment. So that is where that process happens. So if you ask a question, well, how do I know I have the right document? Well, hopefully the planner and the person setting up the production line already had those in front. So by the time the
Okay.
operator sits down, the operator's not going to sit down and then go looking for a document, go looking for a tool, go looking for it. The operator should be sitting down and ready to work. Now the work instruction kicks in, and that's where it's now. What do you need? First of all, you need a unique identifier, the document number, and you need the document title. But that's it. The next step should be pick up part A and part B and put them together. So
Okay.
it's a very different way of thinking.
It sounds like it. And there's an awful lot there in that overview. But I think that the take-home lessons for me is really there's an increased focus on not just having the information somewhere, but where's the best place for that information to be? And what I hear you saying is there are options. really, how do we structure those documents? How do we write those documents in order to achieve those specific outcomes will be something that we'll want to take a look at. So really what we're talking about is a holistic approach throughout the document lifecycle, from the time that a task is identified as needing to be done. We need a procedure or some set of instructions that tells the person who is going to perform that specific task how to do that, the sequence of steps, the expectations. And then eventually the process is going to change. We're going to find opportunities for improvement. We're going to find things that need to be adjusted, tweaked, changed, etc. How do we manage those changes? So in terms of that life cycle, how can we use lean principles to really write our documents better? And then how do we manage those controlled documents more effectively through their life cycle? It occurs to me that we've started talking about lean principles and teed this up, but we haven't at this point gone in and really described what lean principles are.
So lean it's usually attributed to the the Toyota production system in Japan,
Mhm.
and I'm sure that the principles probably go back to the ancient Greeks, but at that point in time, World War II had just finished, and Toyota could not afford to waste a lot of resources. So lean really was about the elimination of waste, and waste comes from defective product, excess inventory, excess motion, overproduction, processing waste, transfer. So they identified the 7 forms of lean, but in the context of a manufacturing plant to make cars.
Okay.
That was the context. And then the thing is, I've practiced lean in the manufacturing context, and many times what happens is, well, my manufacturing process is lean, but I'm waiting for this document, and I have to wait because this quality system process is takes too long. So unfortunately that becomes an excuse for, well, since the quality system process takes so long, well, let's do these big batches of product, and all of a sudden we just undid all the work that we had on lean because now we're trying to accommodate the inefficiencies of the quality system process. And
Okay.
because I'm a manufacturing engineer, my heart is in processes. So in the second half of my career, when I started getting into quality systems, I'm like, wait a minute, this process is broken. The process of identifying the need for a document and then making that document available to somebody, that's a different set. So there are actually 2 forms of waste. There's waste in the document itself, which causes people to do a lot of reading and unnecessary. There's a lot of information that's going along for the ride, but there's also the process of creating documents. And that's the hidden part because, unfortunately, in labor based cost accounting, we're only concerned about what the operators are doing, and everything else is in this cloud called overhead.
Overhead.
But the real waste happens in the creation of documents. So we have the document errors, we have the document handling time, the amount of work we do, the actual processing, the fact that we have too many documents. So in one of my many career situations, I saw a document control department getting recognized. Oh wow, they've really made everything lean. Well, what they really did is they shifted all the responsibilities to everybody else. So basically, all they had to do was rubber stamp the document. And look how efficient I am. Well, that
Wow.
wasn't so efficient for the design engineer, for the procurement people. So all they did is they created what's called a local optimum. But what they did is they shifted everything. So the overall efficiency of the document process was not only not helped, it was actually hindered.
Oh
So
boy.
too
Okay.
often companies management rewards local optimums without understanding what it does to the entire process.
Sure.
And that
So
is
if
why
four or
we
five
need
other
to.
people,
Right. So
yeah.
when
It,
we look at quality systems, we have to look at the quality system processes. And there are many. There is the design control process. There is the process of creating and updating documents. There's the CAPA process. So in my mind, every one of these is fair game for the same lean principles that I applied on the production floor. So that's really
Yeah.
where it came from.
Okay. And so when you talk about waste, I think it's important to reemphasize that it's not just about scrap or about excess material. What we're talking about and what really gets to efficiency and effectiveness and let's face it, job satisfaction, right? If it's difficult to do, if it takes a long time, or there's so many steps in the process, or there's so much information that I have to sift through to understand what's important to me in my job right now in this minute,
Right.
all of that is waste. And we can have a focus on being faster, which is what we typically refer to as efficiency. Well, we can take this process that used to take a week and now it takes 2 days. Well, that's great. But at the same time, there may still be opportunities in that 2 day process that are unnecessary or not value added or, um, any of those adjectives. So I get your point that you're making with the example of the document control group made their jobs a lot easier. They take something, stamp it as approved, a batch record, for example, or a device record. And oh, yeah, well, we print this out, we sign it, and then we send it off. Look, we can do that in 4 minutes. So don't blame us for the operator not having the device record when they need it, right?
Exactly.
But everything else around that is still full of opportunities. In addition to eliminating waste and focusing on efficiency, which again is largely a time-based descriptor, what are some of the other benefits of taking a lean approach to how we write, use, and manage our documents?
Well, first of all, it by having what I call not just what I call a single source of truth, by the very act of not repeating information, you minimize a source of error. Because every
Okay.
time you repeat something, you may repeat it perfectly the first time, but when somebody updates it, they might forget to find all the other places it was repeated. So now you've got discordant information in your quality system. But also, if you understand a clean, consistent structure, you're going to be better prepared for audits because you are able to present a coherent story. And if you have a very structured approach, and I'll talk a little bit about the structure a little bit later, but it actually helps you. And the problem is we try to make things for audit at the expense of the operator and everything else we do. And that's a
No,
false choice.
that never happens.
That's
Wow.
yeah,
I've
that's a
never
false
seen
choice.
that ever.
Yeah, I know.
The sarcasm is just, oh, you struck a nerve, Jose. Yeah, we've
You know, we do everything for the auditor, and we give the auditor a gold mine of opportunities to find the errors, and we are very efficient at creating those errors. So,
Absolutely.
so, but it's a false choice because if you have a coherent story to tell, then the auditor can start as why are we doing this? That's the policy. What are we doing? Those are the SOPs, and how to do it are the work instructions. So
Mhm.
right off the bat, you're by putting the correct structure, you're avoiding that repetition. Guess what? You also have increased efficiency and productivity because now people can focus on the document is actually meaningful to them. They're not dealing with a lot of extraneous information. And even more importantly, you avoid the risk of somebody doing a job they're not qualified to do. And that can be
Right.
very risky. You
Right.
also have this agility in design and manufacturing. In that example I gave of the R&D engineers, well, if they're developing a new product, it's easier for them to just change the product design part without having to update all those procedures. And then the process might be almost identical. And so now it's much easier to make both manufacturing improvements and the product design improvements. So you actually you instead of your resources wasting their time with this non-value added activity, they're actually able to get right on and do their jobs. You also
But
have
isn't there
reduced
value
risk.
there, if I may, if isn't there didn't we just make the case for writing that 29th version of the same process document for the 29th product? Is
Yes.
in that case, I can see the logic, and I think it's important to state what might be obvious, but yet needs to be said. These are opportunities to improve. It's not that we're going about and doing things wrong or that our logic is flawed. There are often very good reasons for why. For example, an individual would say, yes, having a product specific document for this process makes a lot of sense because I've got everything I need for product X in one spot. And I don't have to worry about sifting through a bunch of stuff for products A, B, C, and Y, and Z to try and get at product X. So I just wanted to reemphasize for folks that we're not telling you if you have these systems in place or using this logic that it's flawed. It's just we want to pose a different way of thinking about things that may be better in a lot of different ways.
And you, whenever you're talking, you're triggering a lot of flashbacks at different points in my career. And
I'll
one
bet.
of
I'll
them is
bet.
you said, well, this new piece of equipment. Well, this takes me back to when I was running a maintenance department in a campus of 9 buildings, and my dispatcher would get a call and say, "Can you send a mechanic out to fix a regurgitating confabulator?" And I'm at the what? Oh yeah, it was just installed. Well, how come? Why am I finding out right now? So it really got me thinking about where in the process was the right place for the maintenance department to find out that this equipment was being put there. And obviously, it's not when the equipment breaks down. So
Right.
I started looking at another quality system process, which has to do with process validation. The correct place to
Right.
do that is when you're ordering the equipment and you're writing the installation qualification protocol.
Hmm.
Because when you're getting ready to install, that's the time to say, hey, maintenance, do you have the spare parts? So everything, one consistent theme is doing things at the right point in the process,
Hmm.
as opposed to waiting until the last minute. And if you look at almost every company I've been in, there's a monster change control form with 50 questions, and everybody and his uncle has to sign off because it touches every function in the plant. Now, the question is, why do we have at the very 11th hour, you're asking all these questions? Well, these are questions that should have been answered much earlier in the process.
Hmm.
And because those signals weren't there at the very 11th hour, and this is when the management is saying, hey, we got to get this product out the door. We're going to miss the convention. We're going to miss the release. And all of a sudden, everybody's asking these questions that had never been asked before, and you're scrambling. So
Right.
nobody's happy with that situation. So it's really important. It's not so much about how fast you work or how efficiently, but if you do things in the right sequence, you're going to
Hmm.
work at a much more relaxed pace, and you have time to really think through. So
And that's really where that process mindset comes from and is valuable because if we can think about things a little bit more holistically and preemptively and ask more questions up front during the early process and making sure that the initial parts of whatever process you're going through or um, are rigorous and all the right people are involved at the right stage can save you time, energy, and headaches later on when crunch time happens. Am I hearing that correctly?
yes, yes, absolutely.
So, getting back to writing those documents, let's take the example first of you have an operating procedure like a batch record that's utilized by an operator or a technician that is out on the manufacturing floor. And then maybe our second example could be a procedure that is much more cross functionally related, but from a single point of use an operator is going to use a work instruction, for example, to assemble or do their part of the assembly process of a medical device, what should that document look like? What are some questions that authors should be asking themselves? And how can they make sure that when they're writing that document, it's as effective, efficient, and lean as possible so that the operator gets everything they need and nothing they don't?
So that brings up a good point. So when you're talking about a single user, one of the things that does not belong in there is roles and responsibilities. Because by the time that operator sits down, the roles and responsibilities have been defined, and it is that operator's role. It's understood that their role is to assemble that part. So we can skip the roles and responsibility section also.
Okay.
Um, the operator is doing that job, but one of the things we don't want to just start blindly assembling parts. So there's nothing, one of my favorite phrases in the regulation is shall contain or refer to. And the operator, it's okay to ask the question, do you have the device master record? Do you have the proper documents in front of you? And you don't have to say what it is, but do you have them? Is it there? Does everything match? Do you have the tools? Yes, yes, yes. Okay. Okay, now pick up part A, pick up part B, and so forth. So it's okay to ask a few questions. What you don't want to do is fill that up with a whole bunch of cross references that are already handled somewhere else. So if it's simply
Okay.
prompting you to make sure you have your device master record portion, and this is another point, many companies think of the device master record as a 50-page document. The regulation shall contain or refer to. So there's nothing wrong with breaking your device master record up into a BOM structure where you are focusing on the part that you're assembling, but not only the part, but also what you need for it. So
Okay.
there's many different ways to mix information up. So
Yeah.
if the operator is
It
doing
occur
this,
it occurs to me that now are you suggesting that perhaps that 50-page document, that 50-page batch record or device master record gets broken up into, let's say, 10 segments, and each segment is 5 pages, but it's specific to a unit operation? How would you respond to, well, Jose, you've just increased the need for me as a document control manager to manage 10 different documents as opposed to one? How does that fit in with this concept of making things lean?
so you are going to create those documents anyway because you have to account for all those parts in different places.
Right.
So what I'm suggesting is there's an overarching device master record that has the high level assembly, just like
Mhm.
you would in a BOM, and then it's going to refer to the lower levels. So that
Okay.
way, when you're focusing on a particular assembly, you not only have the information on the part, but you also know who the supplier is. So now this becomes a unit a unit of information that has exactly what you need to manage that particular sub-assembly.
Okay.
So
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 each unit operation has its own chunk. And
right,
to your point, you're putting 50 pages worth of a document together anyway,
right,
whether it's, 10 5-page segments or it's a 50-page, you're still creating 50 pages. And I guess we could say, well, maybe you make each one of those segments 4 pages because you don't have a lot of redundant information. Walk us through the value of really having those unit operations captured in their own independent yet related and referred to chunk, if you will, if that's the way to think about it.
yeah. So one of the things that comes to mind is, well, for that I'm going to need a database so that I can manage all these things. And unfortunately, when I talk about lean documents, people are already looking for a software solution. And I'm telling them, no, you need to. I've configured software. And if you have a paper system that is convoluted, the software is going to make that convoluted system work very efficiently at creating a lot of a mess. So
Yes.
you are actually helping yourself to prepare for future software by organizing these documents. Now, this manifests itself in many sections. For I mentioned that one of the hats I wore was going into the stockroom and picking my parts. Now, most people have a functional mindset, so it's like, okay, all the plates, I'm going to put them in this part of the stockroom. All the nuts are going to here, all the bolts here, and all the other washers. Well, you have four sections of the stockroom, and yet you're going to pick the parts for just one assembly. You're going to spend 30 minutes walking all over that stockroom. So maybe the answer isn't to have that functional mindset. Maybe the answer is in your stockroom you have all the components stocked for that assembly in one place. And then you
I
go
just had a
in.
flashback to Legos
Yeah,
and the individual in the individual packets, right?
that's
Oh
it.
wow. Okay. Yeah,
So
absolutely.
so that's one
Okay.
of the things I did in my startup. I rearranged the stockroom so everything you're gonna set up this part. Well, guess what? Everything's right there. So now you took 30 minutes and now it takes 5 minutes to get the batch information, the lot information to make that lot. So
Okay.
that mindset helps you throughout your process. It helps you in line clearance, it helps you in document management, but the problem is not software. The problem is that you have to rewire the thinking process that has been drilled into you for decades.
Right.
Yep.
Right. If I pick up that package, that kit, and I take it back to my workstation, at that point, I can verify that I have each one of these parts according to a diagram. That individual bolt or plate or nut or whatever circuit board, whatever it happens to be, may not have the identifier on it. Or maybe it does. Maybe it has a tag on it or something along those lines. But I'm anticipating the questions that come up in terms of how we've traditionally managed components and the identification of components, trying to prevent mix-ups. What if the stockroom technician mixes up and puts the wrong bolt into this kit? How is the operator going to know? All of these questions that come up. I imagine that there's a way to do that even in your lean document for that unit operation. Just real quickly, how would you address that particular concern to
So
avoid those
so think
mix-ups?
about, first of all, what is the chance of a stock person picking the wrong bolt? If you have a whole wall of kits of bins with different types of bolts and you're saying, "Oh, pick up this one," and they got interrupted and they picked up the wrong one, that's a mistake right there. However, if you had everything in the stockroom already organized by only the bolts that go with that kit,
Mhm.
there's very little chance that he's going to go and walk and pick up bolts for another kit. So right there at the
Okay.
stockroom level, you already eliminated a potential source of error.
So
Now,
you're not necessarily eliminating the organization of the stockroom. You're building two layers of organization into your stockroom. One is the um, identification and segregation of each individual component, and then the collation of the kit or the putting together the kit in the Ziploc bag so that the operator or whoever is pulling that kit for that unit operation doesn't have to do the sifting through the bins at that one point.
right,
They're all there and they're segregated, but the thing that gets grabbed for the unit operation is the one kit that's already been verified by a second individual to
right.
contain all of the right things. The operator can then do a quick check based on diagrams in the unit operation document, lean document they have, and say, yep, I've got this, I've got this, I've got this, I've got that. Maybe it's to scale, all those sorts of things, to verify all the Lego pieces are there, if you will.
So it if you're talking about nuts and bolts, there's always a risk somewhere that the wrong one is going to get attached to the wrong label. So
Mm-hmm.
it depends on the criticality, and it depends on your tolerance for risk. So if you have those, and I want to correct one thing. I am not putting 2 layers of organization in my stockroom. I am reorganizing it along kits. I am no
Okay.
longer concerned about the nuts here, the bolts here, and the all the other stuff. I am. If you think about the way Amazon tried to organize its warehouses by things, and they finally created this generic bins, and the robots, they just go and pick up random parts. It no longer matters. And that's something I've read about. I haven't experienced it, but the whole mindset is, you know what? It's just a location, and you go to this location and pick up this part.
Yeah.
So in reality, that location now becomes the location of the kit.
Okay.
And by default, the parts that belong there are in that location.
Okay.
So now the operator, if it's a really critical part, yeah, you probably want to have the part in a Ziploc bag with a label, or you want to have something that makes it very difficult to misidentify it.
Mm-hmm.
So I would say, depending on the criticality, you might want to do just that. So that would be, a second line of defense, to have it in a either label or something on the part, and then the operator
Okay.
can verify it. So
Okay.
there's many different things. In that scenario, we actually found something else. We were working in a clean room, and instead of passing the parts through the clean room wall, we actually ended up setting small shelves inside the clean room with the kits already there. So the line clearance, as soon as we're finished, we already had the kit and we were setting up for the next line. So once you
Okay.
start thinking in terms of lean, everything lines up in a process. And then you had a dual Kanban system where here's kit A, kit 1, kit 2, the same parts. As soon as that one's empty, that sends a signal to the stockroom to replace that one, while the production line is consuming the first one. So you're
Okay.
setting up a system of signals. So
Which
anyway,
can
I've tried.
reduce error and improve efficiency as well if you have that. And I realize we got into a lot of lean processes and things along those lines. It's all related. Well, we certainly have covered a lot of ground to this point. Applying lean principles to our controlled documents starts with thinking about those documents differently. Doing so naturally leads us to think then about our processes and systems differently. And as Jose said many times in different ways, it's not just about reorganizing and trimming. The central theme to me so far is being rigorously intentional about each section or paragraph or even each sentence in a document. In part 2 of our discussion, Jose offers even more tips for writing lean documents and optimizing workflows. We'll also talk about some clever ways to determine if your efforts to go lean are working to make a real difference out on the floor. So join us for that and more next time here on The Grind.
If Medvacon can help you and your organization, we're happy to do so. We specialize in the following areas: quality and compliance, validation and qualification services, project management, tech transfers, general and specialized training programs, engineering services, and talent acquisition. If you have general questions as well, feel free to give us a call at any time. We can easily be reached at 833-633-8226 or via our website at www.medvacon.com. Thanks so much, and we look forward to speaking with you.
Thank you for listening to the Quality Grind podcast, presented by Medvacon. To learn more or to hear additional episodes, visit us at www.medvacon.com.